Blockchain and cybersecurity, strengthening digital protection. Blockchain technology is often associated with cryptocurrency transactions because it is a more secure method of sending protected, secure transactions. However, what many don't know is that blockchain can also be used for business purposes to send protected, more secure communications that are safer than traditional networks. So how does cybersecurity play a role in current blockchain technology? Cybercriminals are increasing the frequency and sophistication of cyber attacks by pooling their knowledge and leveraging new technologies. Their use of artificial intelligence, AI, machine learning, and botnets help them perpetrate cybercrime more efficiently, causing more profound and widespread damage. Traditional solutions alone are often insufficient to meet modern cybersecurity challenges. So we must explore other approaches for improving information security, including blockchain technology. In addition, businesses have faced new challenges, such as mitigating vulnerabilities when more staff work remotely, using personal devices and new collaborative software to connect and transmit data to business networks. This post helps organizations manage the 3 steps required to drive successful, secure blockchain implementation. What is blockchain? The blockchain, according to IBM, is a shared, immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. It is a system for tracking anything with value securely, transparently, and cost-efficiently. The name blockchain comes from the fact that each transaction is recorded as a block of data. A block might record one or more data types, such as quantity, price, or location. These blocks become a chain as the asset moves from owner to owner. The chain contains the details of each transaction, including their times and sequence. A blockchain has no single point of failure. Every chain is immutable, so no participant can break a link to insert a block. It's almost impossible to tamper with one of these cryptographic chains because an agreed consensus mechanism validates the accuracy of every transaction in the chain. The owners of assets on blockchains can be practically untraceable, making the technology useful to cybercriminals receiving ransomware payments in cryptocurrency, such as bitcoins. However, businesses and cybersecurity professionals can also use blockchain technology. While blockchain is known for cryptocurrency transactions, such as the Ethereum blockchain platform, blockchain use cases, current and future, vary. Blockchain technology can be advantageous to any use case that would benefit from a secure, transparent, decentralized network, including blockchain types. While a blockchain has inherent security advantages over other networks, cybersecurity benefits and required solutions differ according to the type of blockchain implemented. There are 2 kinds of blockchain, each necessitating different cybersecurity considerations: public and private. Public blockchains. Anyone can join a public blockchain and can do so anonymously. This blockchain ecosystem uses internet-connected computers to validate transactions and provide the agreed-upon consensus. Bitcoin remains the most prominent example of a public blockchain. Consensus is achieved via Bitcoin mining, using computer resources to solve cryptographic puzzles to create a proof of work by which to validate each transaction. A public blockchain does not have many identity and access controls. Authentication and verification are largely carried out through public key encryption. Private blockchains. In contrast, private blockchains rely heavily on identity controls, mostly through digital certificates, using these to make the blockchain private through membership and access privileges. Typically, a private blockchain only allows access to known entities and organizations. Consensus is achieved on a private blockchain via selective endorsement. Known users with privileged access and permissions verify transactions and maintain the ledger. Due to tighter controls, private blockchains can be more likely to satisfy an industry's regulatory and compliance requirements. How cybersecurity impacts blockchain technology. Cybersecurity is built into blockchain technology because of its inherent nature of being a decentralized system built on principles of security, privacy, and trust. In addition to transparency, cost efficiency, and enhanced security, it is fast. Data on a blockchain network is delivered in real time, making it useful to anyone who wants to track assets and see transactions end-to-end, such as payments, orders, and accounts. It's important to note that viewing transactions or transmissions may be instant, but due to encryption and serialization processes, each record can be slow to upload compared to typical data networks. Blockchain's inherent cybersecurity benefits include the following. Decentralization. A blockchain uses a decentralized distributed ledger system rather than relying on a single trusted central authority. With distributed ledger technology, DLT, transactions are recorded across every network node, so cybercriminals face challenges viewing, stealing, or modifying data. It is designed to create trust amongst participants in areas where trust is hard to come by. Strong encryption practices. An infrastructure of asymmetric cryptographic keys and digital signatures is often core to blockchain technology, providing verification of data ownership and data integrity. In some cases, these elements eliminate the need for passwords, an attack vector through which cybercriminals frequently gain unauthorized access to accounts and networks. Immutable records. Nobody can modify a recording on a blockchain ledger. If a record contains an error, it can only be rectified by making another transaction, in which case both transactions will be legible. IoT protection. With increasing applications in various industries, Internet of Things, IoT, devices are often targeted by cybercriminals due to their inherent vulnerabilities. Blockchain provides additional protection for those using IoT devices. Preventing DDoS attacks. A distributed denial of service, DNS, attack aims to overload a server with requests. It requires a focal point to target, typically an IP address or a small group of IP addresses. Data privacy. While its transparency is a prime benefit of using blockchain, with everyone able to see immutable transactions, a permissioned blockchain network will allow only trusted networks to view or participate in transactions. This can be achieved with minimal governance. Furthermore, blockchain lacks the traditional targets sought by cybercriminals, making it more challenging for them to achieve unauthorized access by targeting privacy rules. Smart contract security. Smart contracts are sets of rules stored on the blockchain that trigger transactions when the conditions are met. This automation makes payments more convenient. Blockchain remains secure because its components are tested for authentication, data security, access control, and business logic validation. Traditional cybersecurity best practices and blockchain. When implementing an enterprise-level blockchain network, whether to track currency, orders, accounts, or other digital assets, traditional cybersecurity best practices will enhance blockchain's inherent security advantages. If you find this video useful, don't forget to like and subscribe to our channel.